Hello, students. Today we are meeting here to start with the next topic in the chapter sets. So, till now, we already know what is a set and how to write the set in roster form and set builder form. The next topic we are going to discuss today is empty set. What is empty set? The name itself tells you the set doesn't have any element in it. Such a set is called empty set. For example, if I say set A is X such that X is a student of class 11 presently studying in school. That means we can go to school, we can count the number of students presently studying in your class, and then we can write the names of all such students and we can make a set. So this set contains finite number of elements. Finite number of elements means we can count 1, 2, 3, 4, 5, 6, like that. How many students are there in your class? 40 students are there in your class, for instance. So we can say there are 40 elements in this set. When I list the students, total 40 elements are there. When you are able to count the number of elements in the set, you call the set as a finite set. So A is a finite set. Now we will write another set now. B is a set X such that X is a student presently studying in both class 10 and class 11. So I have to go to the school. I have to see the students. I have to go to class 10. I have to count the number of students. I have to go to class 10, 11, count the number of students. But the logic is, can a student study in both 10th and 11th class at the same time? You take your case only. You are the students of class 11. But are you studying class 10 also? No. You have already passed class 10. You need not study again. You came to class 11. So, we can find no student studying in class 11 as well as class 10. No such student exists. So in my set, I cannot write any student's name. No student, no element. That means this is empty set. B is empty set. So exactly what is empty set, or what is void set, or what is null set? A set which has no element in it. Such a set is called null set, void set, empty set. Usually, you denote the empty set by phi. That means phi is nothing but this set. You must not get confused. Now we will take the next topic, that is finite sets and infinite sets. Already I have told you, but I'm telling you again. What is a finite set? A set having finite number of elements. You can count the number of elements. Such a set is finite set. And what is infinite set? A set having infinite number of elements. Many elements which we cannot even count. Let us take examples for finite set and infinite set. For example, W is a set which has X such that X is day of the week. So day of the week means it can be Sunday, it can be Monday, it can be Tuesday, it can be Wednesday, it can be Thursday, it can be Friday, or it can be Saturday. Apart from this, nothing else. You can count the number of elements in this set. 1, 2, 3, 4, 5, 6, 7. And you can say there are 7 elements in this set. That means this is an example for finite set. Now suppose if I give you an example like this, G is a set having X such that X is a point on a line. That means you have to take a line and count the points. For example, P1 is a point, P2 is a point, P3 is a point. Like this, if you see, there are many points on this line. You can't even count how many points are there. So because you cannot count how many points are there are infinite elements. So such a set is infinite set. Okay. So usually infinite sets you cannot write in roster form because you cannot write the complete set in roster form. You can just like, for example, I will say n is having x such that x is a natural number. So if I want to write natural numbers, can I write all the natural numbers in a roster form? I'll have just to write 1, 2, 3 and leave it. Write dots and leave it. Because I can't sit and write all natural numbers. So all infinite sets cannot be completely written in the roster form. Okay. The next is about equal sets. Suppose I give you two sets. Set A having elements 1, 2, 3, 4. Set B having elements 3, 1, 4, 2. First of all, you can see the number of elements in the two sets are exactly same. Here you have 1, here also 1, here 2, here also 2, here 3, here also 3, here 4, Here also form. Exactly the same elements, only the order is different. Such sets are called equal sets. The set A is equal to set B. So what is the definition for equal sets? Sets A and B having exactly same elements. Exactly same elements. Such sets are called equal sets. A equal to B. Let us take an example. A is a set having X such that X is prime number less than 6. Not only that, I have to list these prime numbers. What are the prime numbers less than 6? 2 is a prime number, 3 is a prime number, 5 is a prime. Now I will give you set B. I will say it has X such that X is a prime factor of 30. So what are the elements? 2 is a prime number which is a factor of 30. 3 is a prime number which is factor of 30. 5 is a prime number which is factor of 30. So you can see the sets A and B are exactly equal. 2, 3, 5, 2, 3, 5. So in this way, we have completed the conceptual part. We will go to exercise 1.2. We will start with the first question in exercise 1.2. First question. Which of the following are examples of null set? First one, set of odd natural numbers divisible by 2. Now, we know that the numbers which are divisible by 2 cannot be odd numbers. They are even numbers. But we are supposed to write odd natural numbers. That means no odd number is divisible by 2. So I cannot write any odd number which is divisible by 2. It is empty set. Second question. Set of even prime numbers. So I have to write a set which has even number which is a prime number as well. So 2 is a prime number, 2 is an even number. So this is not an empty set because it is having the element 2. Whereas the first example is for empty set. Next, we can take the third one. X such that X is a natural number. X is less than 5 and X is greater than 7. So when I write the set, I cannot write any number which is less than 5 and greater than 7 at the same time. So I cannot write any such number. That means this is empty set. Okay, fourth one. Y such that Y is a common point to any two parallel lines. So when I write the set, I will take two parallel lines and I have to see the common point. Two parallel lines never intersect. Say they don't have a common point. Parallel lines never intersect. So these parallel lines do not have a common point at all. No common point. I won't write anything. So it is an empty set. Okay, let's go to question number 2. Which of the following sets are finite or infinite? First one, the set of months of a year. If you have to write the months of a year, you will start from January, February, March, April, May, June, July, August, September, October, November, December. So I completed writing all the months of a year. And I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 elements I can count and tell. So this is a finite set because I can count. Second one, 1, 2, 3. This set has many elements which I can't even count. So this is infinite set because it is going on, never ending. If I write the set 1, 2, 3, 99, 100, even though I cannot write all the elements, even though I can't sit and count, but still I can say there are 100 elements in this set. Without counting itself, my logic will tell. So this is a finite set. Next, fourth, the set of positive integers greater than 100. So if I start writing after 100, the positive integers 101, 102, 103, like this I will be going on writing, never ending. Greater than 100, many numbers are there. So it's not countable. That means this is infinite set. Let's go to fifth example. The set of prime numbers less than 99. To write the prime numbers less than 99, we can write 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Like that, I can sit and write. There is nothing wrong about it. I can even count it. It will take some time, but I can count it. You also can write. Do you know what are the prime numbers less than 99? Any idea? You all know a few prime numbers. Up to where you know? I have already written some prime numbers. Can you continue after this? 17, 19, 23, 29. After that, 31, 37, 41, 43, 47, 53, 59. Like that, it will go up to some extent only. 61, 67, 71, 73, 79, 83, 89, 97. Even though it is difficult to write, difficult to count, but still you can write it and still you call it as finite set because it stopped, like it is not continuing. That's what I'm telling about finite set and infinite set. Okay. Now we will go to question number 3. State whether each of the following set is finite or infinite. First one, the set of lines which are parallel to x-axis. Suppose if you take x-axis and parallel to x-axis you start drawing line. This line is parallel to x-axis, this is parallel to x-axis, this is parallel to x-axis. Like that you will be drawing continuously, there is no end for it. So there will be many such lines. That is why this set is infinite set. I hope it is clear very well. The second is the set of letters in English alphabet. If you want to make a set letters of English alphabet like A, B, C, D up to Z, it's very easy to write. You can count how many alphabets are there. The set ended, it is not continuing, it ended at Z. So such a set is called finite set. Third one, the set of numbers which are multiple of 5. So I have to take multiples of 5. 5 ones, 5 twos, 5 threes, 5 fours, 5 fives, 5 six, 5 7. One second. Okay. 5 6, 5 7. Like that I will be continuing. Multiples of 5 are never ending. So this is infinite set. They are never ending, we can't count. Fourth, the set of animals living on earth. If you start counting the animals living on earth, it will never end. How many animals, small animals, big animals, how many are there? You will be counting, counting, counting. So it is infinite set. Because you can't sit and count the number of animals. Practically, it is infinite. But logically, if you see, animals on earth cannot be many. They cannot be uncountable like stars. So logically, you can count them as finite set. Practically, you can't sit and count, but that is why I said infinite. You can't sit and count the number of animals. But finally, the number of animals will be finite only. There can't be infinite animals. If there are infinite animals, there will be no place on the earth. That is okay. Next, fifth one, the set of circles passing through origin 0, comma 0. So if you have origin 0, comma 0, how many circles you can draw? You can draw many circles passing through origin. We can't even make a list. So this is infinite set. Okay. Next question, fourth one. We'll go to fourth page, next page. Okay, question number 4. In the following, state whether A is equal to B or not. First one, A is a set having A, B, C, D. And B is a set having D, C, B, A. So you have A in both, you have B in both, there is C in both, and there is D in both. So I can say A and B are exactly same, equal. Okay, second, A is the set having 4, 8, 12, 16. B is the set having 8, 4, 16 and 80. So here A and B are not equal because A is having 4, B is having 4, A is having 8, B is having 8, A is having 16, B is having 16. But A has 2 and B has 18. So exactly they are not same. A and B are not equal. Okay, third one. A is a set having 2, 4, 6, 8, 10. And B is the set having X such that X is positive, even, integer, and X is less than or equal to 10. So I have to write positive, even, integer. So I can start with 2 is an even, positive even, 4 is positive even, 8 is positive even, and then 10 is positive even integer. Now you can see 2, 4, 6, 8, 10 are present in both. That's why you can say A and B are exactly same. We'll go to question number 4. A is having X such that X is a multiple of 10. So multiple of 10 means 10 ones, 10 twos, 10 threes, 10 fours. Like that it continues. So this is multiple of 10 is infinite set. Now B is a set having 10, 15, 20, 25, 30, 35. They are becoming too small. I will write again. So in B set, you have 10, 15, 20, 25, 30, and so on. I can say A and B are not equal because in B you have 15, which is not there in A. B you have 25, but that is not in A. That's why they are not equal. Let's go to question number 5. Are the following pair of sets equal? Give reasons. First one, set A is having elements 2, 3, and B is having elements X such that X is solution of X square plus 5X plus 6 equal to 0. So first we will take the equation X square plus 5X plus 6 equal to 0. We will find the solution by factorizing it. And so X will be -2, -3. -2, -3. So B is the solution set, -2, -3. Clearly you can see the set A is not equal to set B because set A has all these elements, set B has all these elements. And I can say A is not equal to B. They are different. Second one. A is a set having X such that X is a letter of the word follow. That means in A you have letter F, O, L, and W. I'm not repeating O and L again and again. Next, B is the set having Y such that Y is leather, here I have to write Y element is there in set A. Y is a letter of the word wolf. So in wolf, I have W, O, L, F. You can see F is present in both, O is present in both, L is present in both, W is present in both. So easily we can write the sets A and B are equal. Let's go to question number 6 on the new page. From the sets given below, select equal sets. That's the question. So I'm giving some sets. A is a set having elements 2, 4, 8, 12. B is the set having elements 1, 2, 3, 4. C is the set having elements 4, 8, 12, 13. D is the set having 3, 1, 4, 2. E is the set having -1, 1. F is the set having 0, A. G is the set having 1, -1. And H is the set having 0, 1. So which two sets or which sets can be called as equal? You can see here you have 2, 4, 8, 12. Anywhere 2, 4, 8, 12? No. 2, 4, 8, 12, I don't have anywhere. So I can't take set A. Set B, I have 1, 2, 3, 4. Same way in D also I have 1, 2, 3, 4. Same elements. So I can say set A and set D are equal. One second. The pen wasn't writing. So I can say set B and set D are equal because both are having 1, 2, 3, 4. Similarly, set E and set G are equal because both are having elements -1, 1, -1, 1. That's it. Remaining all the sets are different. Let's go to next example or next question. Okay, state, we will do some additional questions. State which of the following sets are finite or infinite sets. So first one, the set having x such that x belongs to set of natural numbers and x minus 1 into x minus 2 is C. So clearly I will have x equal to 1, x equal to 2 because these are the solutions. And with solutions, I'm making a set. 1 is a solution, 2 is a solution. So the set is ending. That means it is a finite set. Next, second. The set X having X such that X belongs to natural numbers and X square is equal to 4. So X square is equal to 4 in natural numbers. That is 2. That's all, only one number because 2 square is 4. You can see 2 square will be 4. So it has only one element, but I can call it as finite set. Next, the set having x such that x belongs to natural numbers and 2x minus 1 equal to 0. So to write the set, I have to take 2x minus 1 equal to 0 and I have to find the solution, which is 1 by 2. So I have to write this 1 by 2. But 1 by 2 is not a natural number. That means I cannot write any number in the set. It is a null set. Null set means no number, easy to count. So this also comes under finite set. Next, fourth one. The set having x such that x is a natural number and x is a prime number. So you have to take natural numbers, that to prime numbers. So what are the natural numbers which are prime numbers? Just now we have made a list. 2, 3, 5, 7, 11, 13, 17, 19, so on. The list of prime numbers which are natural numbers. So it continues. It never stops. You cannot even stop it. Such an example is for infinite set. Next one, the set X having X belongs to N and X is odd. Natural numbers you have to take which are odd. So 1, 3, 5, 7, 11, 13, all these are natural numbers. And all these are odd numbers also. Natural numbers and odd numbers. But they are never ending, they will go on. So this is an example for infinite set. Let's go to the next question or next example. That is question number 2. Find the pairs of equal sets giving reasons. A is the set having 0. B is the set having x such that x is greater than 15 and x is less than 5. So what are the numbers I can write for B? A number greater than 15 and less than 5. That's not possible. You can't get any number. This is what we have for B. It is an empty set. But A is having 0. So I can say A is not equal to B. Now coming to C. C is having x such that x minus 5 is 0. That means in set C you have only solution 5. So here you can see A and C are not equal. B and C are not equal. Next, D. X such that x square equal to 25. If x square is 25, x I can say plus or minus 5. Lastly, E. E is the set having x such that x is positive integral root of x square minus 2x minus 15 equal to 0. I can factorize this. X minus 5 into x plus 3. So x I'm getting 5 and minus 3. So I have written all the equations A, B, C, D, E. Can you find any similarities? Can you find any two sets to be equal? Yes, see the set E. See the set C. See the set E. Are they equal? Here you have only 5. Here you have 5 and minus 3. But minus 3 is not acceptable because we have to take only positive integral root, only 5. So from this we can say C and E are equal. Remaining all are different roots. They are not equal. Different sets. Now let us take third example. Which of the following sets are equal and justify your answer? First I will write X. X is set of letters in the word alloy. So I will write A, L. I will not write second L. O, W. Y, sorry. If you see the set X, you have A, L, O, Y. L you need not write 2 times. Now B is the set of letters in loyal. So for B, I will write Loya. I will not write L again. But you can see in the set X and in set B, you have the same elements. A, L, L, O, O, Y, Y. So I can say set X is equal to set B. They are equal sets. Similarly, one more. I'll give you set A having n such that n belongs to integers and n square is less than or equal to 4. So, n square less than or equal to 4. So, minus 2 square is 4. Minus 1 square is 1, which is less than 4. 0 square is less than 4, so I can take that. 1 square less than 4. 2 square equal to 4. I can take these. Now in B, x such that x belongs to set of real numbers and x square minus 3x plus 2 equal to 0. So you have to take x square minus 3x plus 2 equal to 0. Find the solutions x minus 2, x minus 1 or x equal to 1 comma 2. So the roots, the solutions which I got are 1 and 2. But if you compare A and B, they are not equal at all. You don't have same elements in A and B. So with this, we completed the exercise 1.2 and the topics related to that. Now we will go to the next topic and we will be doing next exercise also if the time permits. I don't think we have sufficient time, but whatever we can cover, we will cover in this class. So we are going to learn about subsets. What is subset? Suppose X is the set of your school. Set means students of your school. That is X. And suppose in that you will have Y. Y is students in your class. So you can see Y is subset of X because in Y you have students in your class. In Y you have students of your class which are students of the school also. All the elements of Y are present in X also. They all are students of your school also. That is why I can say X and Y if you take. Y is subset of X. Y is subset of X. This symbol is used for subset. So what is definition for subset? If I say A is subset of B, what do I mean? Every element A belonging to A must be present in B also. All the elements of A must be present in B also. Then we can say A is the subset of B. Or I can say if A belongs to A, then it implies A belongs to B also. This is subset definition. Suppose if an element of A is not element of B, then we say A is not a subset of B. So first you have to observe carefully what is there and then decide whether it is a subset or not. Let us consider this set. Q is the set of rational numbers. R is the set of real numbers. So think carefully. Rational numbers are real numbers also. That means all the elements of Q are present in R also. Q is subset of R. Okay, next example. A is the set of divisors of 56. What are divisors of 56? 1 divides 56. 2 divides 56. 4 divisor of 56 we have to take. Does 4 also divide 56? 3 doesn't divide, isn't it? I'm sure 3 doesn't divide. But 4 will divide 56. 5 will not divide. 6 will not divide. 7 will divide. 8 will divide. What about 9? 9 doesn't divide. Why we are taking all these? 1 times 56. 156 is 56. 228 is 56. With 3 it won't come. Then 4 14s are 56. 7 8s are 56. So we have already taken 1, 2, 4, 7. Now we can write 8, 14, 28, 56. So these are divisors of 56. Now what is B? Set of all prime divisors of 56. What are prime divisors? These all are divisors out of which prime are 2, 7. That's all. So you can say B is subset of A because 2, 7 is present in A also. That is the meaning of subset. Let us take one more example. Suppose A is having 1, 3, 5 and B set is having X such that X is an odd natural number less than 6. So odd numbers which are less than 6, 1, 3, 5, only these you can take. So all the elements of A are present in B, all the elements of B are present in A. A is subset of B and B is subset of A. Then I can say A and B will be equal. See, A and B sets, they are equal. So always for equal sets, A will be subset of B, B will be subset of A. One more example. Suppose A is having A, E, I, O, U. And the set B is having A, B, C, D. Then all the elements of A are not present in B. All the elements of B are not present in A. So A is not subset of B. B is not subset of A. Okay. Then there is something called proper subset. What is proper subset? Proper subset means A can be subset of B, but A should not be equal to B. then I will say A is the proper subset of B. A is proper subset of B. I can say this. And also I can say B is the superset. A is proper subset of B, but B is superset of A. So we have discussed about just subsets. We will continue with the next topic. We will do some examples and then I will say that we have completed the sets after finishing all. We have more topics in this section. We will do it in the next class. With this, I am ending the class. Come to the class, next class, prepared.